All right, so we're going to be doing lesson 814 today, factoring completely. Okay, so we're going to be considering expressions that can be factored first with a common factor, and then again using the quadratic factoring method, which is our diamond and box method. And so the hope was that you've already done number 35. Okay, if you haven't done 35 yet, A, B, C, and D, go ahead and pause this video and try them on your own first. But if you have done them, here are the answers you should have gotten. You can check them here. All right, so 3x minus 2, 3x minus 2 for A, 9m plus 1, 9m minus 1 for B, x minus 4 and x minus 7 for C, and now D. As you can see, I did this problem in two different ways. I got 3n plus 3, n plus 2, one of the ways, and the other way I got 3n plus 6, n plus 1. If you did one of those methods, then you are correct. It's just this one had two possibilities. So what we're going to be talking about today is focusing on ones that do have two possibilities and why they have two possibilities. Okay? There's something special about D as compared to A, B, and C that made D have two possibilities, whereas the other ones didn't. So let's go ahead and turn. And we are looking in our book at page 380, which is where this lesson is, 814. And I'm looking at problem 836 now. I'll go ahead and put it up here. All right, but it'd be nice for you to get your book out if you don't have it. Okay, it says compare your solutions for problem 835 with the rest of your class. So that's what we just did. I just showed my class my problems for 835. And the question is there more than one factored form of this? And I just showed you that there is. I showed you two possibilities. Okay? And so, I'm going to go ahead and write, yes, there is more than one possible answer. All right. So then it says, why, where are we? Why does it have more than one factored form while the other quadratics have only one possible answer? Look for clues and in the different factored forms. Okay, so my question to you is, I want you to look at this. What was different about D than A, B, and C? There's one distinct possibility, or one distinct difference that allowed it to have more than one. If you know that difference, write it in on part B there on the next page. Okay, so I don't know if you're in the class right now, if someone wants to raise their hand and volunteer what's different about D and than the rest of them, you can do that now. All right, so here is the difference. I don't know if this is what was just said or not. Okay, this one has a GCF. The other ones do not. This one has a greatest common factor that can be taken out first. All right, so that is how you know whether it will have more than one possible answer. So that is what we can write on B if you haven't already written it. There is a GCF on problem D. So that should allow you to take a look at C here, which says, without factoring, predict which quadratic expressions may have more than one answer, more than one factored form. Okay, and so you should just be able to look at the ones that have a GCF. Which ones are they? This one has a GCF. That one would have more than one answer. This one does not have a GCF. Okay, that one would have only one answer. Okay, this one has a GCF. Okay, that would have multiple ways of writing it in factored form, but this one does not have a GCF again, so again, that would have only one. Okay, so I'm looking now at my book, looking at the next page, 381, 837. It says an expression is considered completely factored if, and I'm just taking this straight from the textbook, none of the factors can be factored anymore. None of the factors can be factored anymore. So if I were to do this one, 10x squared plus 25x minus 15, this one's this problem above. We circled it saying that there would be more than one possible way to factor it. Okay? But that is if you don't pull out the GCF first. What we want to try to do is look at the problem and see if we notice that there's a GCF first and do that part first. Okay, so from now on, anytime you're looking to factor something, the first thing you're always going to look for is a GCF, no matter what, no matter whether it has 2 terms or 3 terms or any more. You're looking for a GCF first. What is it? You can blurt it out. Yes, it's 5. Okay, I'm going to take out a 5 from all of these and fill in the parenthesis. That's 2x squared plus 5x minus 3. All right, so what we have to do now is, and I'm reading this from the book, your result in part A is not completely factored if either factor can be factored. Okay, so in other words, this right here, this looks like a regular diamond and rectangle problem, so we are going to factor this part now. Okay, instead of factoring it from the beginning, we're just going to factor this. Forget about the 5 for now. Let's turn this into our diamond. Okay, remember the top of the diamond is 2 times negative 3, and the bottom would be 5. And we think to ourselves, what multiplies to make negative 6 and adds to make 5? Okay, this times this, so what would it be? 6 and negative 1 would multiply to make negative 6, but add to make 5. Okay, if you thought 3 and 2, because you saw the 5 down here, remember, since one of them's negative, it can't really be 3 and 2. All right, or 3 and negative 2 or something like that. So now we go to our rectangle. Okay, and remember, we're not looking at the original problem, we're looking right here. 2x squared goes there. Our negative 3 goes down here. And then these two numbers, 6x and negative 1x, go in those two spots somewhere. All right, so now fill out the dimensions and finish this problem. Hopefully you're writing 2x here and x here. Unless you put your 6x down here, then you would have these flipped around. Okay, 2x times 3, so that's an x plus 3 there. X times negative 1, so that's a minus 1 right there. So now here we have it, 2x minus 1, x plus 3. I'm going to write 2x minus 1 x plus 3. But don't forget about this 5. We took that 5 out at the beginning. That's still one of the factors. When you pull out a GCF, it doesn't go away. It stays in front of your final answer. So your final answer is 5 times 2x minus 1 times x plus 3. Those three things would multiply together to make 10x squared plus 25x minus 15. So that is our method of completely factoring. So go ahead and try these problems down below. All right, just a hint. You have to take out the GCF first. Okay, so you're always, both of these have a GCF. Look for the GCF first. I'm going to take the 5 out there. Then you're going to take this expression here, x squared plus 3x minus 4, and make your diamond and rectangle. Okay, so you're factoring this now, and then you're going to get your final answer by putting a 5 in front of it. All right, so I'm going to give you some time to work on this. I'm going to take this sheet away and work on it on my own here while you guys are trying them. Okay, I'm ready to show my answer, so you guys should pause the video until you're ready to see the answer. If you'd like, we could send a couple volunteers to the board to do these. So while you're doing that, you can pause the video. All right, here are the answers that I got. Here I got 5 times x minus 1 times x plus 4. Here the GCF was not just 3, it was 3x. So I took a 3x out, leaving me with x squared minus 2x minus 15. Finished the diamond and rectangle. And then wrote my final answer of 3x times x plus 3 times x minus 5. If you need to pause this video to take a look at it, please do. And that pretty much concludes our lesson here for 814. All right, so you'll be practicing these on your 814 assignment. Good luck.